Hi, this is Kumaran. In today's video, we will discuss about addition of two 8-bit numbers with carry. In the series of programming, I will continue this addition program. So 8-bit addition, you know that binary addition, it's a straightforward addition. So for the assumption, we have taken that F6 and AE available on memory. Both we have to add. The answer should be stored sum and carry. So 8-bit addition with carry, this is the task of the program. We have assumed the data from the memory address. So let's add this in manually, then we will implement the same in. So F6 means you write in binary F6. So F6 in binary, F means it's 1111 is F6 is 0110. In the 8421 form you write. Then AE A is 1010, E is 1110. Okay. So add this. 0 plus 0 is 0, 1 plus 1 is 10, 111 is 1110, here it is 10, here it is 111 is 11, 1 plus 1 is 10, 111 is 11. So here this is sum, this one is carry, this one is carry flag, this is sum is 4, here it is A, so you will get A4. So this memory, the output should be A4, here the carry should be 01. So carry is either 0 or 1, only two options we have. But the carry flag is available as a flip-flop. We cannot copy that flip-flop. We have to check the carry flag with the help of conditional instructions. Then if the flag is 1, we have to write logic 1 on the corresponding register as 01. So we'll add this in terms of programming. For carry we will use, so before writing program we formulate which register we are going to use. For example, I am going to use this one in one register. For addition means always we have to use one accumulator, one of the data. The other register you can use any B, C, D, E, H, L. For example, L register I am going to use. Then for borrow I am going to use that E register. Sorry, carry here. For carry I am going to use E register. So we'll take this, start the programming, this LDA, first memory. Because addition we don't have precedence, A plus B equal to B plus A. That's why we are taking that first number, copy to L register as per our algorithm. Move L comma A. Now take that second number in accumulator, LDA 4201. For addition we are following this, but when you perform subtraction means we need to follow the precedence. So the first number minus second number, in that case we have to follow the precedence. So now we have to clear the E register for carry, because it might have some data by the previous program. To clear that we will use that move immediate 00. So this LDA, LDR direct addressing, this one is immediate addressing. So whenever the data is with the programmer, for example here 00 is with the programmer, that's why we are loading. But we don't know what data available on the memory, that's why we are using that memory addressing, direct addressing. So add both, add with L register. Add L means A plus L, answer in A, because A is default inherent operator. Now we will check the carry flag. Suppose no carry means store the result. Suppose carry occurs, we have to increment this C register plus 1 because carry is maximum 1. That's why we are incrementing. So increment instruction is INR E. So now carry is on E register, sum in A register, store the result. To store the result, instruction is STA. Accumulator content will be written on this corresponding address what we are mentioning. So 4202. Now the carry is on E register, that to copy to A and use, because we are using direct addressing, all from accumulator only we can copy. So move A comma E, then use that STA, the next memory address 4203, the halt. You stop the program after this. So here we have a label store, what it has to skip. Suppose no carry means we should not increment this, only it has to skip this step. This step is here, so you skip. Here you write that store. So here the label is, you can use any label. Okay, so this is what the program for 8-bit addition with carry. The same program we will perform in simulator. Let's check this result also. 8085 simulator we have. So you know that procedure to get the data will have 4200. What number you have taken for the sample? F6AE. So we'll have that F6AE 00. Output memory also we have to initialize with 00. So we'll take this LDA 4200, copy this to L register. Here no comma, only space. Get the second number LDA, LDA 4201. Initialize E register to count the carry. Add now, add L. Jump no carry, store. Suppose carry occurs, increment E register, then store the answer. Here store label colon space, then you type your instruction STA 4202, then copy the carry from E register to A register and store in the consecutive memory location 4203, and halt. So the program is over. Let's compile the program. It's no error, compiled. So execute one by one, we will verify. So the second number is taken into, first number taken to A, copy to L register, get the second number in A, clear the E register, add A plus L, we have sum A4, carry is 1. So here carry is 1, that's why it will not skip. So increment E register by 1, store the answer in next memory A4, carry is copied to A and transferred to memory. The answer you got. So that's it about addition of 8-bit numbers with borrow. Thank you.